Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to all of you students. Thank you for joining the Google Meet session for our class today. This is week number 5. So we have been discussing about dynamics course for 4 weeks now. This is the first class in week 5. And today we are going into the last subtopic in chapter 1, kinematics of particles. That is the relative motion analysis of two particles. So this is the title of the subtopic that we are going to discuss today. Okay, so before we continue, let's look at the lesson outcomes of what you should be able to achieve, or you should be able to grab throughout this lesson, throughout the class today. So the first one is to understand the difference between absolute and relative motion. Okay, so we will discuss about this later, where we will see what is the meaning of absolute motion and what is the meaning of relative motion. And then we are going to derive several equations. Okay, based on relative position, we are going to derive the equation for relative velocity and also relative acceleration. And then we are going to solve one or two problems, one or two relative motion problems of two particles to wrap up the lecture today, the lesson for today. Okay. So in the previous class last week, I have shown you what we have covered in kinematics of particle. Apa yang kita telah belajar so far. So basically we have learned the first one was rectilinear motion, straight line motion. Under rectilinear motion, we have discussed three subtopics: continuous motion, constant acceleration, and erratic motion. And then we go to the curvilinear motion, where there are also three subtopics: rectangular coordinate, normal and tangential coordinate system, and finally cylindrical component. And last week we discussed about the absolute dependent motion. This was topic number 3. And today we are going to cover the last component of chapter 1, the last subtopic of chapter 1, that is the relative motion analysis of two particles. Okay. All right. So basically we will be finished with chapter 1 this week, and then on Wednesday we are going into a new chapter. That is the second chapter, the kinetics of particles. Okay. Let's look at the difference between absolute and relative position. What do you understand by absolute and relative position? Ada tak siapa-siapa yang tahu? Basically, I think you have learned about this in physics, maybe in physics during your SPM or basic physics early in your diploma. Have you learned or heard about absolute and relative position? Ada tak siapa-siapa tahu? Anyone can give me an answer. What is absolute position dulu? Ada tak? Ammar Ashraf ada? Apa yang you faham tentang absolute position? Yang lain? Suara saya boleh dengar tak ni? Can you hear my voice?
Boleh ke?
Boleh. Okay. Ada siapa-siapa nak respon kepada soalan saya? What is absolute position? Ada siapa-siapa tahu? Tak ingat?
Pastilah saya.
Tak ingat. Okay. Tak apa. Let's give the definition of absolute. Absolute position ni bermaksud, the meaning of absolute position is the position with respect to a fixed origin ataupun reference point. Maksud dia, kita ada satu fixed origin yang kita jadikan sebagai reference point, and by referring to that point, position of anything, any particle, any object with respect to that fixed origin is called absolute position. Okay, so apa lawan dia? Absolute tadi with respect to fixed origin. So relative ni ialah the opposite of absolute, which is with respect to translating reference point, ataupun translating kat sini moving reference point lah. Maksud dia absolute tadi reference point kita tetap fixed, not moving, but for relative position it is with respect to a moving reference point, a translating reference point. Okay, let's look at a graphical punya representation supaya you boleh faham dengan lebih jelas. Okay, do you see this picture? Ni gambar, let's say this is at a beach lah, for example, and can you see a man standing on the shore, dekat atas pasir ni, looking at the beach? Okay, boleh nampak kan gambar ni? Can you see the picture clearly?
Yes, we can, sir.
Okay, good. Okay, so imagine this man is standing on the beach, and then there comes another man on a boat. Okay, on a boat, bergerak di atas air ni lah, bergerak on the water, on the ocean lah. Okay, and then after that, the man on the shore, this man here, this guy standing on the shore, he also see an incoming or a duck swimming from the other side of the beach. Okay, so let's say, macam saya explain sebelum ni, let's say we have a remote control, a very powerful remote control that we can pause the motion. Kita boleh berhentikan pergerakan ni. Benda ni semua sedang bergerak. This man, this standing man is not moving, tapi the man on a boat as well as the duck is moving. Okay, we can then say that this man standing on the shore as the origin, the fixed reference point. Okay, as if dia ialah kita punya origin of the coordinate system. Dia yang tetap tidak bergerak. So we can say that point O is the origin, the observer. Orang yang berdiri ni, this standing man is observing the motion of these two objects. A man on a boat is moving, as well as the duck is moving. And this man is fixed. Kita assume dia tidak bergerak. This man, point O is fixed, not moving. Let's call that this man on a boat as point A. Okay, point A. This man on the boat as point A. Therefore, we can draw a position vector. Okay, position of A with respect to O. Okay, O is a fixed point. RA is the position vector of A, of the man on a boat, with respect to the man standing on the shore. This is a fixed point. So RA ni, is this an absolute position or is this a relative position? Based on the definition yang saya bagi tahu tadi, RA di sini, adakah ia relative position atau dia ialah absolute position? Which one?
Absolute.
Absolute position, betul. Because as our definition just now, absolute position ialah with respect to fixed origin. Jadi kita bagi tahu tadi, that man on the shore is fixed. Dia ialah fixed origin. So RA ini ialah position of the man on the boat with respect to a fixed origin. So RA ialah absolute position. Okay. We can also get the absolute position of the duck. Let's call the duck as point B. Okay. So we can draw another position vector RB from the man on the shore, from the fixed origin to the duck. So this one, is it an absolute position ataupun relative position? Which one? Absolute ke relative? Guys?
Absolute.
Absolute, betul. So, whatever is referring to the fixed origin O is called absolute position. Okay? So, RA and RB are absolute positions with respect to origin O. Okay? The man on the shore is not moving. It is observing the motion of a man on a boat. Dia sedang memerhatikan the man on the boat moving, as well as dia juga memerhatikan a duck swimming on the ocean. So we can get the position of A with respect to O, RA. We can get the position of the duck B with respect to the standing man, RB. Okay, so these two are absolute positions. Now, let's say this man on a boat now wants to observe the duck that is swimming on the ocean as well. Okay, remember sebelum ni, this standing guy is observing the man on the boat and the duck. Now the man on the boat also want to observe the duck. This guy at A wants to become an observer also. Okay, but this guy is moving. Remember, this guy is moving, is traveling. So if we draw a coordinate system on this moving guy, then we draw as x, y, z prime. Okay, to differentiate with the origin. Yang origin ni kita dah lukis x, y, z. So for this guy on a boat, kita namakan dia sebagai x prime, y prime, z prime. So this guy is moving. Tapi this guy wants to observe the duck. Dia nak tahu apa position duck ni with respect to himself. With respect to the moving guy on a boat, apa position duck. So we can then draw A again is a translating reference. Okay, dia bergerak. So we can draw the position of the duck with respect to the moving guy on a boat. Okay, A to B. So this position vector is called RB/A. RB, the duck, the position of the duck with respect to A, with respect to the man on the boat at point A. So kita tulis dia sebagai RB/A. This RB/A is the relative position of B with respect to A. Okay, saya zoom sikit sini sebab kepala saya dah block. Okay, RB/A is the relative position of B with respect to A. Okay, ada apa-apa soalan tak? Ada yang tak faham tak tentang ini? So O is not moving, is a fixed point. Dia observe point A and dia observe point B, the duck. So RA and RB is absolute positions with respect to O. The man on the boat at point A is also observing the duck. So the position of the duck with respect to the man on a boat is then RB slash A. This is the one that we call as relative position. Ada apa-apa soalan?
Understand, sir.
Boleh faham eh? Okay. I give you another example. Let's say you are standing on the side of a road. You berdiri di tepi jalan. And then you see an incoming car, ada satu kereta driving at 100 km per hour, passing by you. Okay, so you nampak kereta tu bergerak dengan 100 km per hour, passing through you, you berdiri di tepi jalan. There is another guy on a motorcycle. Dia pun tengah bergerak di atas jalan dengan let's say 80 km per hour. That guy is also observing the car travelling at 100 km per hour. If you imagine the situation, you yang berdiri di tepi jalan, you akan nampak kereta tadi dengan bergerak dengan kelajuan 100 km per hour. Tapi orang yang berada di atas motor yang sedang bergerak 80 km per hour, dia tak akan nampak orang yang naik kereta tu 100 km per hour. Mesti tak sama because the guy on the motorcycle is also moving. Whereas you on the side of the road is static, is not moving. So in that case, you are the origin. The guy on the motorcycle is point A lah, is a moving reference point, and the car is the object that is moving. So you observe the car as well as the guy on the motorcycle also observe the car. So you on the side of the road will see the car traveling at 100 km per hour, whereas the guy on the motorcycle is observing the car traveling at another speed. Dia tak akan nampak you the car travel at 100 km per hour also, because the motorcycle is also moving. Boleh you imagine situation tu tak? Boleh?
Boleh.
Okay, so itu serba sedikit explanation berkenaan absolute position dan relative position. Okay, so if we take out the picture, what we have is then a triangle. So if you can see this as a triangle, then you can imagine this as a vector punya relationship. Okay, this is a vector relationship. By looking at this vector triangle, can you give me what will be the equation that you can write from this arrow here? Apa yang you dapat terbitkan daripada sini? What is the equation that you can derive from this vector triangle? Anyone? Tak ingat vector punya relationship? Ada? Okay, let's go from here. This one goes to here is RA. Okay, RA, the arrowhead is at point A, and then there is another arrow going to B. So you can then write RA plus RB slash A plus this arrow, which is equal to this arrow is pointing towards the same point. So you can write RA plus RB slash A is equal to RB. This is the relationship that you can write or you can derive from this vector triangle. Then if we rearrange this equation to find what is the relative position, you will have RB slash A is equal to RB, the absolute position of point B, minus the absolute position of point A. So RB slash A is equal to RB minus RA. Okay, that is the relative position. How about relative velocity? How do you get velocity from the position? Dalam 4 minggu kita belajar dynamics. How do you get velocity from position? What do you do? Do you integrate? Do you differentiate? What you should do?
Differentiation.
Sorry?
Differentiation.
Differentiation, correct. So you have the position. To get the velocity, you have to differentiate the position over time. So when you do dr over dt, you will get the velocity. Okay, so the same as what you have up here, you will get vb slash a relative velocity of point B with respect to A. This is what this means. VB slash A means the relative velocity of B with respect to A is equal to VB, the absolute velocity. Yang ni with respect to apa? With respect to the origin O. Sama macam ni lah. The absolute is referring to the origin O, the absolute position. The relative position is referring to a moving point. So same goes for velocity. VB and VA is the absolute velocity, and VB slash A is the relative velocity. Okay. So in these equations, VB and VA are called absolute velocities, and VB slash A is the relative velocity of B with respect to A. Okay. And note that if you change the direction, then it will be negative. So VB slash A is equal to negative VA slash B. Okay, VA slash B ni means the velocity of A with respect to B. Now B becomes the origin. Okay, whatever written at the back here is the reference point. So kalau B slash A means that velocity of B with respect to A as the reference point. Kalau A slash B, it's the velocity of A with respect to B. B is then the reference point. Okay, so that is the relative velocity. To get the acceleration, you do the same. You have VB slash A is equal to VB minus VA. And then if you differentiate the velocities here over time, you do dv over dt, you will get the equation for acceleration. Okay, so B slash A, the relative acceleration of point B with respect to A is equal to AB, the absolute acceleration of point B, minus AA, the absolute acceleration of point A. Okay? Do you have any question? So basically we have derived three equations, three relative motion equation. One is for position. RB slash A is equal to RB minus RA. Okay, RB slash A is RB minus RA. And then we have the equation for relative velocity. VB slash A is equal to VB minus VA. And finally, we have the equation for relative acceleration. AB slash A is equal to AB minus AA. And if you notice, all of these parameters or variables, they have arrow on top, which means that these are all vector quantity. Okay, apa yang ada arrow on top ni bermaksud dia ialah vector quantity. What is the difference between vector and scalar? vector has direction, scalar has magnitude only. Vector has magnitude and direction. Dia ada kedua-duanya. Okay, do you have any question on the relative motion? Any question?
Ada.
Jelas?
Jelas.
Okay. So if there's no question, maybe we can look at a few examples. But before that, I would like to recap on a few trigonometry rules ataupun law di mana this might be useful when solving problems in this subtopic. Okay, so laws of sines and cosines, if you remember, A divided by sine A is equal to B divided by sine B is equal to C divided by sine C. Ini satu law of sines. And then there is also law of cosines. A square is equal to B square plus C square minus 2BC cos A, and so on. So if you are not familiar with this, I think all of you are familiar, but maybe you forget the equation. So you need to go back and do some revision on this lah, because trigonometry will be used a lot in solving dynamics problem. Okay, so kalau tak ada apa-apa soalan, if you don't have any question, let's look at a few example. Okay, this is example number 1. So please read the question first while I prepare my iPad. Okay, let's read the question. Two planes, A and B, are traveling with constant velocities. Okay, determine the magnitude and direction of the velocity of B, of plane B, relative to A. Okay, the question is determine the velocity of B relative to A. Okay, apa yang kita nak cari ni? VA ke, VB ke, VB slash A? Which one? VB slash A. Okay, apa yang kita nak cari is VB slash A. Velocity of plane B relative to A. Okay, there are two methods to solve this. One is using vector, the other one is using trigonometry. Macam yang saya tunjuk tadi. So I will show to you both methods, and you will decide lah which method that you would like to use. Let's look at vector method first. Okay, before we solve any problems, we should first define our coordinate system. So let's define, this is a two-dimensional problem. So let's define the coordinate system, the normal coordinate system lah. X is positive going to the right, Y is positive going up. Okay, this is a standard coordinate system. Okay, and remember, VA and VB, apa yang kita dah tengok dalam in my slides just now, they are all apa nama dia, vector quantity. So we need to write VA and VB in vector punya notation lah. Okay, so VA in vector. How do we write VA in vector? What is given here, VA is equal to 650 km per hour, is a scalar quantity. Okay, but we need to write in vector quantity. How do we write it in vector? How do we write in vector? Okay, sebelum tu, let's zoom into the coordinate system. What is the unit vector for x-axis. Kita dah ada discuss ni beberapa kali. What is the unit vector untuk x-axis?
I.
Okay, unit vector for x-axis is I. Okay, I have also explained in the previous class. Unit vector normally kita tulis dengan ada macam topi or hat on top of the letter. Okay, untuk y component, what is the unit vector?
J.
J, good. So for y component, it's J. Okay, so going back to kita punya VA tadi, so how do we write the velocity of A in vector form? 650 I ke J? I, good. I, because it is in x-axis and you see that it is traveling to the right, which is in the positive direction of x-axis. So it will be positive lah. 650 I and the unit is kilometer per hour. Okay. Now let's write VB. How do you write VB? Now, if I draw the vector VB, it is pointing in this direction. This is VB. How do you write this vector VB? This is a vector in form of vector. I ke J ke? How do you write this?
So should we resolve it?
Yes, you need to resolve in two components because VB now has two components. Okay, I will zoom in. So to resolve, you see the vector is pointing down, so there must be one vector going to the left, which is VB I. This is VBI, or in x-axis, and there must be one vector going down. This will be VB in VBJ in the first one VBI in x-axis and then VBJ in y-axis. Okay. How do you calculate what is VBI and what is VBJ?
Sin 60, cos 60.
Okay, sine 60 and cos 60, betul? So which one is multiplied with cos 60? Which one is multiplied with sine 60?
Sin dekat y axis.
Betul, good. Okay, you see given here 60 degrees di bawah, which means that over here is also 60 degrees. Okay, this angle near to the x-axis. Okay, so what we write is, and you also can see that the component is now, the x component is pointing in the negative direction of x-axis, and also the y component is also pointing in the negative direction of y-axis. So both components will be negative. Okay, so what we have here is negative 800 multiply with cos of 60 degrees. This is I component. Okay, and then minus again 800 multiplied with sine of 60 degrees, and this will be J component. Okay, boleh nampak? Alright, so when you calculate, you will get 800 cos 60. What do you get? Minus 800 cos 60. Okay, Chia has given the answer, minus 400 I minus 800 cos 60 is equal to minus 400. And then minus 800 sine 60 will be 692.8 J, and this is in kilometer per hour. Okay, so VA you have, VB you have. Alright, so now what we want to determine is VB slash A. Okay, what you want to determine is VB slash A. So according to our formula just now, what is VB slash A? What is VB slash A? Okay, VB slash A is equal to VB minus VA, right? The absolute position of B, VB minus VA. Alright. Okay. So, then we will substitute the values minus 400 I minus 692.8 J. This is for VB, and then minus 650 I. This is for VA. Okay, so how do you solve this? What would be the value? So VB slash A is then what is the answer?
Negative 1050 I.
Okay, good. So what you do is you have to look at the unit vector. So I is always with I. You cannot add I and J. Okay, so J doesn't have anything to add, so it will remain as 692.8 lah. Whereas for I component, you have 400 minus, you have minus 400 and minus 650. So you will get minus, yang ni dua ni you tolak kan, so basically it will become minus 1050 I and minus 692.8 J. Okay, meter per second. Kilometer per hour. Kilometer per hour. Okay, we did not convert the unit, so it will stay as kilometer per hour lah. Okay, then this is one answer. Okay, this one. And then you can also calculate the magnitude. Yang tu macam biasa lah. You can calculate the magnitude of the relative velocity. Okay, so VB slash A, when you calculate the magnitude, it is no longer a vector. Maksudnya kalau you tengok di sini, dia dah tak ada arrow lagi on top, because it is not a vector anymore. It is a scalar quantity. When you calculate the magnitude. So when you calculate the magnitude, it will just become a VB slash A lah. So what you do is you square I component and J component and square root of both components. So you will get 1050 square plus 622.8 square, and then square root. You don't need to even key in the negative sign, because negative sign is only to show the direction for a vector quantity. So when you calculate the magnitude, you can just ignore the negative sign. So you will then get VB slash A magnitude that is equal to 1258 kilometer per hour. Okay. Alright. Okay, so basically if we draw the vector VA, if this is point A, if this is point A and this is point B here, okay, so basically you have no, we need to have point O also. Wait, okay, so VA will be here, VA, and then you have VB pointing this way, and then this will be VB slash A is like this. Okay, because it is also the direction is also we also need to find the direction here. In the question it says what is the direction as well, so we need to find the angle theta at which apa ni, the relative velocity is acting. Okay, so macam sebelum ni we use tangent, so we can use also tangent to find theta. So basically theta is equivalent to tangent of arctangent of the component in y-axis divided by the component in x-axis. So arctangent of 692.8 divided by 1050. So you can calculate this arctangent of these two to get theta is equal to 33.4 degrees. So basically theta here is with respect to the horizontal axis, or with respect to the x-axis. So basically theta is here. Okay, you can write like that in the final answer to indicate that theta that you provide here is with respect to the horizontal component, or with respect to the x-axis. Okay, do you have any question on using vector to solve to solve the problem?
Excuse me, sir.
Yeah.
Like now, velocity b slash a, which means that velocity from A to B, right?
Yes.
Yes, and then yeah, I think that's all, because just now the arrow I see like quite weird, because is it the VA and the VB must, the arrowhead must pointing to each other?
VA and VB, the arrowhead.
Must pointing to each other. They will meet. I mean,
Not necessarily pointing to each other.
okay, can understood.
Which one?
Okay, so,
Which part are you confused? Which part?
about the just now the red arrowhead, the arrow.
Oh, the arrow. Okay, the arrow was. I think the arrow was wrong. Basically, we need to pick one reference. So let's say, in this case, we choose. Okay, I'm gonna draw it again. Let's say that this is the origin O. Okay, let's say that this is the origin O. Can you see this? Okay, I'm gonna zoom in a little bit. Okay, if this is the origin O, then we can draw VA from the origin O. So basically VA is pointing this way. This is VA, right? and then you have VB pointing in this direction. Okay, this will be VB. So basically, VB slash A is connecting these two arrow here. So this will be VB slash A. All right. So basically, the theta that we calculated just now is to represent this angle here, this angle theta. Can you see this?
Yes, sir.
Yes.
Understood.
Okay. So this is the theta that we basically would like to find lah. Okay.
Okay. Thank you, sir.
Yeah. Okay. So, do you have any question?
Sir,
Yes.
when we calculate that angle, do we need to ignore the simple negative and positive?
Negative and positive of what? Oh yes. You don't need to put in the negative sign.
Oh, okay.
Yeah.
Thank you, sir.
Yeah.
Sir,
Yes.
sir, explain the tangent. How sir get the theta for tangent calculation?
The tangent.
Yeah, how you choose the 692.8 and 101.50?
Okay. Tangent ni tangent is the opposite over the side, right? Did you learn this in previously in school? Tangent is opposite over side, right? Basically, if you look at this triangle here, VB slash A, this part is basically the hypotenuse. So the opposite is VB. How do I indicate this? Okay, this will be the we would like to find the angle theta. So this will be the opposite, and this will be the side. This is the hypotenuse. All right. So that's why you wait. Is this correct? This side. Oh yeah. Because okay, again, let me erase this again. Okay, so basically we can look at the point O. Let's draw point O here. Okay, if you go back to the resolving VB, so this will be VBI. This will be VBI, and this will be VBJ. Right? And yeah, so the side, the opposite. Okay, forget about what I said just now. Okay, the side and opposite tangent is the opposite over side is for right triangle. So this, what we have here is now a right triangle. So this is 90 degrees. Kat sini kan? This is 90 degrees. So the opposite is basically this side is the opposite, and this whole side here is the side, and VBA remains as the hypotenuse lah. So this will be the hypotenuse. Okay, so then tangent theta is again tangent where do I write this? Tangent theta is then the opposite divided by the side. Okay, the opposite here is VBJ. The opposite here is VBJ. Let me highlight with different color. The opposite is VBJ, and the side here is basically VBI plus plus VA plus VA. This is VA over here. So that's why we take the side as the sum of these two lah, minus 400 and minus 650. So this will be the side. Do you understand now?
Yes, sir.
Okay, all right. Okay, now I'm gonna show you another way to solve this by using trigonometry. Basically, we have done a little bit of trigonometry here. So when we would like to solve it using trigonometry, so basically we're gonna draw the same thing. So you start from the origin. Let's pick an origin, let's say here, and then we draw a vector VA. Okay, this will be VA, and then we have another vector VB in this direction. Okay, this will be VB. Okay, then we have VB slash A, which is from here pointing to here, from the tip of A to B. So this will be B slash A, VB slash A. Okay, from point A, this is point A, this is A here, this is B over here. Okay, so we know from the question that this angle, I'm gonna zoom in a little bit, this angle here is 60 degrees. Okay, how do we know this? This comes from the question lah. The angle on the top angle there is 60 degrees. So you also know that this angle will be 120 degrees. Okay, by using trigonometry, can you solve this? Can you solve by using trigonometry to get what is VB slash A? It's basically to find the length of VB slash A. Can you solve this?
Yes, sir.
Using which law? Do you
Using
law of
B
sines?
square is equal to B square plus
Yes.
C square minus
Cosine.
2B cos A.
Correct. Using cosine, law of cosine. So if I go back to the slide, the law of cosines, we need to identify A, B, C, and 2BC cos A. So basically, we can take this side as A. Okay, this side as A, right? This is A, this is B, and this is am I right? This is C, right? C square is A square plus B square minus 2AB cos C. Yeah, so VB slash A from here using trigonometry, VB slash A square is equal to VB square plus VA square minus 2 times VB times VA multiply with cos of the angle between VB and VA, which is 120 degrees. Right. Yeah, okay. So kita substitute lah the values. VB is given by, so if you use this method, you don't need to use vector lagi lah. These are all scalar punya multiplication. Okay, scalar punya quantity. So VB is given as 800. So 800 square plus 650 square. Okay, minus 2 times 800 times 650 and then multiply with cos of 120 degrees. Okay, so can you help me calculate this? I forgot my calculator, so just want to verify whether we will get the same answer like what we have using vector multiplication, vector punya apa method just now. Do you get the same answer like what we have previously? Previously we have VB/A is 1258 km per hour. So do you have the same answer for this one? Anyone, can you help me calculate this? 1258. The same answer?
Same answer.
Same answer. Good. Okay, so 1258 kilometer per hour. Okay. So what does this tell you is that if let's say from any point, let's say we as you or let's say you are standing here, although it is not logical for you to stand di langit sana, tapi let's say you are standing here at point O, so you are observing the plane A traveling at 650 km per hour and the plane B 800 km per hour. But if you stand on plane A now, let's say you are now standing here. Okay, you are now standing here. Let me draw a person there. If you are standing there, then what you are looking if you look at plane B, what you are seeing is that B is traveling not at 800 km per hour but at a much larger speed, that is 1258 km per hour. So that is the difference between absolute and relative motion tadi. So when you are sitting on a moving object as well, observing another object moving also, you might see the velocity of the incoming object which has much larger velocity than as compared to if you stand on a fixed position that is not moving. So if you stand on the fixed position O that is not moving, then you are seeing the absolute velocity. But if you stand on a moving object, then what you see is the relative velocity of the object relative to your position, because you are also moving. Okay, I hope that makes sense lah. Okay, do you have any question? Oh, before that, we can also use this to determine the direction tadi lah. We are also asked to find the direction of VB. So as what we did before, this is actually our theta, the angle of interest with respect to the horizontal reference line ini, or with respect to x-axis. Okay, so basically what you can use to find the angle theta here, you can use sine rule, right? Can you use sine rule?
Yes, sir.
Yes, sine rule, right? So sine rule says that this length divided by the length, the angle of the sine of the opposite angle is equivalent to this length divided by the sine of its opposite angle. Okay, so when we write the equation, it will be VB slash A divided by sine of 120 degrees is equal to VB divided by sine of theta. Okay, so what we want to, sorry, okay, so what we want to find is theta. So you can do some rearrangement. Okay, then you will get theta is equal to the same lah. It should be the same. Theta is equal to 33.4. So can you calculate this? See whether you can get the same answer like before, 33.4 degrees.
Same, sir.
Same, eh? Okay, good. So that is another way to calculate or to solve this problem lah, by using trigonometry. So ada dua cara, either you use vector method macam tadi, or you can also use the trigonometry method. Okay, let's look at another example. Boleh tengok one more example? Okay. At the instant shown, sekejap let me show the problem here first, okay, while I try to fix this. Okay, at the instant shown, cars A and B are traveling at velocities VA is equal to 40 meter per second, VB is 30 meter per second, and VA is going straight up, while VB is going on a curved road. Okay, VB is going on a curved road. If A is increasing its speed at 4 meter per second square, apa maksud dia ni? What do you understand by this? A is increasing its speed at 4 meter per second square. What is 4 meter per second square here?
Acceleration.
Acceleration of apa? Of which car? Of car A, right?
A, yeah.
Yes. Okay. So basically, let's list down all the variable ataupun parameter that we have. So we have VA is 40 meter per second, VB is 30 meter per second, and we have AA, sorry, what's the problem? Let me see. Okay, AA is 4 meter per second square, and it also says here that speed of B is decreasing. B is decreasing at 3 meter per second square. So basically this is AB lah. AB is decreasing, which means that it has negative acceleration. So minus 3 meter per second square. Okay, apa yang kita nak find? determine the velocity and acceleration of B with respect to A. So what we would like to find is what is B with respect to A. So with respect to A means that A is the reference point. So then we write B slash A. B with respect to A. This is what we want to find. And also A, B slash A. So there are two components that we would like to find. Okay. So let's solve this using vector method. Okay. How do we start? We start with defining the coordinate system first. Okay. Let's define the coordinate system. And then if you see here, you will see that dia dah bagi the intersection point. So we can use this as our origin. So let's imagine that this is our origin. This is O lah, point O kat sini. Okay. So we can then draw our coordinate system here. This is one line. This is another line. Okay. So this, let's say this is y-axis and this is our x-axis. Okay. So as usual, we need to write down all of these variables ataupun parameters in vector form. Okay. So let's go with the easiest one, which is VA. Okay, VA vector, the arrow on top. What is VA vector? VA is moving in y-axis, okay, as you see from the picture here, at 40 meter per second going up. So there is only one component of VA. So you will write VA as 40 J positive meter per second because it is going up. So positive lah, in the positive direction of y-axis. Okay. What about VB? What about VB? Okay, let's zoom in here. VB is basically this is point B. So VB is going in this direction. Okay, that will be the direction of VB. Okay. So this is this is VB. Okay. Then we can resolve VB into components lah, into X and Y components. Okay, so we're gonna have one component pointing up, which is in Y-axis. Okay, this is VBJ. Okay, and there is also another component going to the left. Okay, this will be VBI or minus VBI sebab dia going to the left. Okay, so two components of VB, I and J. Alright, so now let's write, sorry again. Okay, so VB okay, how do we write this? Which one is 30 degrees here? Let's zoom in again. Okay, 30 degrees is given here, is given down there, which means that this part is also 30 degrees. This angle here, 30 degrees, right? That angle is also 30 degrees. So VB, the I component, will be multiplied with sine of 30 degrees. Okay, so VB kita dah bagi berapa? 30. Okay, so VBI is negative, so you write minus 30 times sine of 30 degrees I. Okay, and then the J component is positive, so plus 30 cos of 30 degrees J. Okay. So ini dapat apa? What do you get for VB? 30 minus 30 sine 30 will be minus 15, right? Minus 15i, and then 30 cos 30 will be plus 25.98 J. The unit will be meter per second. Okay. Alright, so next apa kita buat? Apa kita buat untuk dapatkan this? What we want to find now is this, VB slash A. Okay. So what is the next step? VB slash A is equal to?
VB minus VA.
Okay, so VB slash A is VB minus VA. Okay, so kita tulis balik, substitute the values, minus 15i plus 25.98j, this is 1, VB minus 40j. Okay, so finally we get VB slash A is equal to minus 15i, and then you have plus 25.98 minus 40. Dapat berapa tu? Minus 14.02, right? 14.02j in meter per second. Okay, sorry again. Okay, so this will be one of the answer. Okay, ini boleh jadi satu answer, and then we can calculate the magnitude. Okay, VB slash A, the magnitude, this will be 15 square plus 14.02 square and then square root. Okay, so berapa dapat ni the magnitude? What do you get for the magnitude?
20.53.
20.53, okay, 20.53 meter per second. So this will be the magnitude of VB slash A. And also we want to find, ada dia tanya direction tak? Determine the velocity and acceleration of B with respect to A. Okay, dia tak ada tanya direction, tapi kalau kita nak calculate direction, I mean the angle macam tadi, we can lukis balik the apa ni, the vector tadi. Okay, so you have VA 40 pointing up. Okay, so VA ni 40 up, this will be VA, and then VB slightly at an angle of 30 degrees, tapi smaller than VA, that is 30 degrees, 30 meter per second. So VB maybe something like that. Okay, ini VB, and then finally you will have B slash A is this one lah, VB slash A from point A. This is A, this is O, this is B, so this will be VB slash A, and we have the angle here as 30 degrees. So what is the angle, the direction that we want is basically, saya alih sikit ni. Oops. Let me erase this first. This is VB/A. So basically the angle that we want is this angle with respect to the horizontal line lah, this angle theta here. Okay, that angle theta is the one that we want to find. Yeah. So how do you find this?
Cosine tu.
Macam mana?
Find the length of VBA.
VBA, yes. Kita dah dapat dah length of VBA, which is this 20.53. So basically kita boleh guna sine rule.
VBA over sine 30 equivalent to VB
over sine sana. Okay, and then kita minus dengan 90 lah. Okay, so your method is also correct. Kita boleh cari angle sini dulu, betul? Let's call this as beta ke, for example. Okay, if we find this angle first, so we can use sine rule. Okay, like our friend suggested. So VB/A over sine of 30 degrees is equal to VB over sine of beta. Okay, then we will get what is the value of beta. Boleh tolong saya calculate tak? VB/A tadi kita dapat 20.53. So this will be 20.53. VB is 30. Okay, what do you get for beta? Let me find my calculator. Do you get the value of beta? 20.53 divided by sine 30 and then 30 sine answer. Okay, so do you get beta equals to 46.94? Semua dapat tak? Beta is equal to 46.94. And therefore, if we zoom out a little bit, kita nak cari apa itu theta. So theta, we know that theta plus beta ni equals to 90 degrees lah. Dia is a right triangle here. Saya boleh zoom in sikit. So basically, these two is equal to 90 degrees kat sini. Okay, this is 90 degrees angle. So beta plus theta is 90 degrees. Okay, theta plus beta is equal to 90 degrees, and therefore we can get theta by 90 degrees minus okay, 90 degrees minus 46.94 degrees, so theta is equal to 43.06 degrees. So you can draw to indicate that this is theta, like that. Theta is sekejap saya zoom in, tak nampak. Okay, theta is basically the angle from the horizontal reference line from the x-axis. Okay, ada apa-apa soalan tak? Is this clear?
Clear, sir.
Clear, eh? Okay. Itu velocity, tapi kita belum lagi calculate the acceleration. Okay, so I will let me copy this first. Let me okay, wait. Okay. Okay, now let's find what is the acceleration AB/A. This is what we want to find now. Okay, okay, given AA is 4 meter per second, and we know that the car A is travelling in a straight line going up. So kita tahu acceleration dia mestilah moving up also. Dia bukanlah pergi ke kiri atau ke kanan. So we can write AA, the vector is, what is AA? 4 meter per second ni 4 apa? 4i ke 4j ke?
4i, sir.
4i. Okay, so sorry, are you sure I?
J, sir.
J kan?
J.
J, positive J, because it is moving up. So 4j meter per second square. That is AA. Okay, now AB. Okay. Now we know that, let me erase this first. AB. Okay, how do we know in which direction AB is pointing? If I zoom in here, how do we determine the direction of AB? Sebab bila kita nak when we want to use vector method to solve this, we need to know the direction of AB. Then only we can resolve into components. So how do we know? Okay, the difference between A and B, car A is travelling in a straight line, so it is a rectilinear motion. What about B? B is travelling in a curved road, so now it is no longer a rectilinear motion. Motion apa kita panggil for a curved motion ni?
Curvilinear motion.
Curvilinear motion. Okay, curvilinear motion. And if you remember, I will bring up the previous slide that we discussed in class when we talk about the normal and tangential coordinate. Okay, so kalau you remember, if you look here, the acceleration component ni dia boleh point in any direction, tapi dia akan ada dua component, which is one tangential component, tangential acceleration at, that is equal to v dot ataupun dv over dt, and there is another component, normal component, pointing to the center of rotation. Center of the arc, okay. So how do we do this? Okay, now going back to this. So basically, which direction is the tangential component? Which direction is the tangential component now? Tangential component dia akan sama dengan direction velocity ni lah, sebab remember velocity is always tangent to the path. So this will be AT, A tangential component. Okay, this will be A of tangential component. And then there is another acceleration that is in the normal component, always in the concave side of the arc. So the normal component will be pointing in this direction. So this will be AN. Okay, the normal component in that direction. Okay, so the acceleration of this is somewhere ke arah sini lah. Okay, somewhere ke arah sini. This is A, which we don't really know the direction yet. So this is what we need to calculate. Okay. Now, how do we calculate AT? AT here, how do we calculate AT and how do we calculate AN? Okay. Now, in the beginning of the calculation, we define our coordinate system as X and Y. So, although the acceleration of the car has tangential and normal component, we still need to calculate both of them using XY coordinate. Okay, so I will erase this first. Okay, kalau ni sedikit confusing, tapi kalau you tak faham, I have recorded this video. Later you can watch baliklah video ni. Okay, so I will zoom in a little bit. So for tangential component, dia akan ada, you can resolve, okay, for tangential component, you can resolve into two components also. There is one component here, ATJ. There is another component here, ATI, like that. Okay, and then we know that this angle here is 30 degrees, okay, which comes from angle yang diberi di bawah inilah. So ATJ will be okay, before that, if you refer to the question, dia cakap B is decreasing at 3 meter per second. The 3 meter per second given here is basically AT. Remember tak tadi saya tunjuk pada you from our previous slide here that let me zoom in a little bit. Let me zoom in here. Okay. You can see here AT, the tangential component is equal to V dot, which means that the component given in the question tu ialah basically AT. AN dia tak beri. AN kita kena calculate. AN is equal to V square over rho. So if you look at the question here, rho is given here. This is why row B 200 meter is given, the radius of curvature, because we need to use this to calculate AN punya component. So yang tu kita buat later. So basically AT ataupun AB here yang kita tulis di sini, AB here is basically is equivalent to AT lah, a tangential component of acceleration of car B. Okay, so minus 3 is the tangential component. So let's first write the tangential component dulu. Okay, saya padam ni balik. You boleh follow ke ni? Ni sedikit confusing lah. Masih boleh follow ke? Boleh follow ke? Boleh okay, so just try to follow me slowly lah. Kalau ada apa-apa soalan, you can always ask terus. Okay. Yeah.
Yeah, AB, AT tu tak faham Ustaz. How sir use AB as AT?
Okay. Because dalam slide yang saya, dalam definition kita sebelum ni, the tangential component, ni tengok tangential component of acceleration is equal to the is equal to dv over dt. V dot here is dv over dt. So what is given in the question here, B is decreasing at 3 meter per second square. Ini basically referring to the dv over dt lah, to the tangential component of the car punya acceleration. Tapi when a car is travelling along a curve, dia akan ada dua komponen. One is the tangential, yang mana dia tengah move tangent to the curve. The other one is the acceleration component pointing to the center of the arc. So yang kita panggil sebagai centripetal acceleration, if you remember from our previous lesson. So whatever is given here, 3 meter per second square here, is basically the component, the tangential component of the acceleration. And the normal component of the acceleration we need to calculate using using v square over rho. So that's why rho is given in the question also, which is equal to 200 meter. Okay, so let's continue. We don't have much time. AT, or I will write as ATB lah, ATB, the tangential component acceleration of car B, because car A doesn't have the tangential component because it is traveling in a rectilinear motion, just a straight line. Okay, so ATB is minus 3. Why minus is because here we have defined that AB is minus 3 meter per second because it is decreasing. The acceleration is decreasing, or it is decelerating. So it is basically slowing down. So that's why it becomes minus. So minus 3 multiply with, if you look at this part here, okay, if you look at this part, there is an angle involved of angle of 30 degrees involved. So we have minus 3 sine 30 degrees I for the x component. Okay, and then for j component is pointing up, so it will be plus, and then you have to minus again. So basically it's going to become minus also, minus 3. Okay, I will just write it in bracket, plus minus 3 cos of 30 degrees j. Okay, so this will be the tangential component of acceleration. Okay, so let's calculate this first. So basically ATB will be minus 3 sine 30, what do you have? Is it minus 1.5? Minus 1.5. So minus 1.5 I, and then minus 3 cos 30 degrees will be minus 2.598. Minus 2.598 J. Okay, this will be ATB. And then remember, there is one more component of acceleration because it is traveling in a curvilinear path. So yang kita calculate just now is only the component, the tangential component, which is let me highlight this, which is this part only, the tangential component. Now we need to calculate this part, the normal component. So this part also, based on xy axis, we can then resolve into components also. So there will be one component in this direction. Let me pick another color. There will be one component in this direction, and there will also be another component in negative y direction. Okay, so this will be ANJ, and this will be ANI. Okay. So tadi kita dah ada AT minus 3 given, but AN is not given, so we need to calculate. So AN, according to our previous lesson, AN is equal to V square over rho. Okay, AN is V square over rho. So we have the velocity of B, which is 30 meter per second. So this will be AN. AN is equal to 30 square over rho is 200. So this will be 30 square divided by 200 is 4.5. Okay, it's 4.5 meter per second square. So AN is 4.5. Then once we have AN, we can then key in the equation lah. So ANB is then equal to the I, sorry, okay, now I'm writing the equation for ANB, the normal component. So the I component, if we zoom in, I component is negative. ANJ component is also negative. So both will be negative. So ANB will be negative 4.5. Okay, what is the angle now? The angle will be 30. Okay, so over there will be 30 degrees also. Yes? This part here, if I zoom in, okay, sorry, it lost again. Okay, so this part here will also be 30 degrees. Okay, can you follow? This part is 30 degrees. So then the I component will be minus 4.5 cos of 30 degrees. Cos of 30 degrees I. Okay, and then
Sir,
yes,
may I ask why the sign of the I is negative?
sine of I is negative. Which one?
A and B, negative 4.5.
Oh, Negative because, okay, if I zoom in, A and I is, when we resolve just now, A and I is pointing to the left, which is the negative direction of x-axis. A and J is pointing down, which is also negative direction of y-axis. Because earlier we have defined this coordinate system, the red color. Can you see it?
Oh, yes.
Okay, so that is the reason why it becomes negative lah.
But for the ATB, the I is negative. I means the ATB.
AT,
The sign.
ATBI, yes, I put negative, right? Here.
Both is negative sign.
Both is negative, yes, true.
Oh, okay.
Oh, okay, I understand. Oh, okay. This should be negative, right? Is that what you're saying? This should be negative 3. So it will be positive lah,
Yes.
isn't it?
Oh, yes.
Yes, okay. Thank you. So the negative 3 is because of the deceleration. Negative, the first negative in front is because of the direction of the axis. Okay, thank you. All right, so let's continue. So A and B is minus 4.5 cos 30 degrees I. And then A and J is another minus 4.5 sine of 30 degrees J. Okay, so you will have here minus 4.5 cos 30 will be minus 3.897 I minus 4.5 sine of 30 degrees is minus 2.25 J. Okay, all right, so then AB will be let me change color. So okay, the AB will be equal to AT B plus A and B lah, both components. All right, so if we zoom in here, both components. So first you will add I and I first. Okay, I and I. So what you have is equal to 1.5 plus 1.5 minus 3.897. Put it in bracket. This is I component, and then we have minus 2.598J and minus 2.25J. So this will be another component plus minus 2.598 minus okay, I'm gonna write it below because we don't have enough space. So this will be plus, okay, minus 2.598 minus 2.25 in bracket J. So we have AB will be 1.5 minus 3.89. What do we have? Minus 2.3 minus 2.397I. Okay, and then minus 2.598 minus 2.25 minus 4.848 minus 4.848 J meter per second square. Okay, so this will be AB. Okay, so basically to find AB is a little bit tricky, and then once you found AB, then it is just straightforward. When we want to find AB slash A is then equal to AB. This is in vector. Okay, I forgot to put all of this in vector. So this is a vector, this is a vector, this is a vector, all of these are vectors. So we need to write the arrow on top. Okay, AB minus A. Right? So then you just do the subtraction lah. Basically it's J minus J. So basically this you will write it as minus 2.397I minus 4.848J minus 4J. Okay, so you will get minus 2.397I minus 8.848J meter per second square. So this will be A B slash A vector. Okay, this one. This will be the answer lah. Okay, and then it's already 4. So the magnitude, I think I don't have to show it again. I think you should know by now how to calculate the magnitude. Basically you just need to square I component, square J component, and square root. You will get the magnitude. And for the angle also, the direction is just by using trigonometry, like what I have shown to you before. Okay, do you have any question? Is it clear on the calculation of acceleration? When it involves a curvilinear motion, then it will be a little bit tricky lah. Do you understand what we have been doing right now?
Yes, sir.
Yes, okay. So if you are confused, if you are still confused, later I will share the video in the Google Classroom, so you can go there and watch it again and maybe try to solve the problem by yourself first, and then if you stuck, you refer to the video and try to do it again over and over again, and then I think you should be able to understand lah. Okay, so if there's no more question, then I think that will be the end of our class today. So in today's lesson, we have learned about absolute and relative motion of two particles. Okay, absolute is by referring to a fixed origin. Relative is a moving reference point. And we derive the equation just now. RB slash A is equal to RB minus RA, and same goes for velocity and acceleration. VB slash A is equal to VB minus VA, and AB slash A is equal to AB minus AA. And then I have also shown to you two examples on problems related to relative motion. Okay, so if there is no question, I think that's all for today's class. I'm sorry to take a little bit of your time. It's past 4 already. So thank you, and I will see you again on Wednesday. And because we have finished with chapter 1, can we do a quiz on Wednesday? Can we do a quiz number 2 on Wednesday? Or do you want to have some time to prepare and we do the
topic, sir?
We do the quiz next week, Monday?
Based on what topic, sir?
Topic I have not decided yet because I have not done the question yet. I think we should do it on Monday lah. I will inform you from which topic the quiz will come from, maybe tomorrow or maybe on Wednesday, and then you will have some time to prepare for the quiz. Can we do the quiz on next Monday?
Can, sir.
Okay.
Okay, sir.
Alright. Okay. So again, thank you for coming to the class. And I will see you again on Wednesday where we will go into chapter number 2. Okay. Thank you, everyone.
Okay, sir. Thank
Okay.
you.
Assalamualaikum.
Thank you, sir. Thank you, sir.